This is the weekly CosmoQuest astronomy slash science slash mission update hour with me, Emily Lakdawalla of the Planetary Society. I blog every day at planetary.org/blog. And joining me and helping me out is Fraser Cain of Universe Today and also of CosmoQuest. You can find him at universetoday.com. And we're here, as we are every couple of weeks, to give an update on what's going on with Curiosity. But as it's been a rather quiet time on the Curiosity mission lately, and because I attended such a cool conference last week in Reno, Nevada, the Division for Planetary Sciences meeting of the American Astronomical Society, otherwise known as DPS for short, I thought I'd give an update on that, and just to keep you abreast of what's going on in science. So let's go ahead and get started with that. But actually, before I begin, I should say, please +1 this, or like this, or thumbs up, or do whatever you can to help let people know that this Hangout is going on. Please share it to your stream in Google Plus or with your friends at Facebook. Do whatever you can to let the word out about what we're doing with these broadcasts. And I know Fraser has so many more excellent broadcasts, like the astronomy.
The virtual star party on Saturday night. Yeah.
Yes, the virtual star parties, which are really quite incredible. And I'll let maybe you can advertise that a little bit later on in the show. But as Fraser said, we only have 45 minutes today. I have a hot date with my husband later, so let's get right on to it. So Curiosity has remained parked at the same site, Rocknest, where she's been for a few weeks now. She has taken 4 bites of soil from that little sand dune. The first 2 were used to clean out the interior of her sample handling mechanisms at the end of the robotic arm. And the third one was finally delivered to the CHEMIN instrument, which is the XRD-XRF, that's X-ray diffraction, X-ray fractionation instrument inside the body of the rover. And then a 4th bite was taken to be delivered to SAM, which is the Sample Analysis at Mars, which is a gas chromatograph mass spectrometer hooked up to basically an oven that heats samples to incredibly high temperatures to drive off gases and help figure out what the composition of the soil is. These are the 2 instruments that really brought Curiosity to Mars. They're the kinds of instruments that have never been sent to the surface of another world before. And so it's going to be very exciting to see what the results are from that, but I do not expect to hear any results from either of those instruments until probably the beginning of December, which is when the American Geophysical Union meeting is going to be in San Francisco.
So are we kind of done with all of these week after week of great big announcements? Like, we've discovered, ancient stream beds, and we've discovered strange foreign objects on the surface. I guess not foreign objects on the surface of Mars. Unless there's like dinosaur bones, the updates won't come quite so fast and furious.
Well, I think that we're definitely at a pause where the shine has worn off the mission. They've been on the ground for a few months, and now people aren't just waiting with bated breath for every single update on a wheel turn to get the rover moving in one direction. Now it's time for us to wait for the results. So I think we're at a natural pause now, and in fact, there's not a press briefing planned for tomorrow, which is I think the first week since Curiosity landed that there hasn't been a press briefing, and I don't think there's anything wrong with that. They're just toward the end of kind of a tedious process, which is checking out the sample handling mechanism. And hopefully they'll get done with that this week, maybe by the end of this weekend, and then they'll start driving again to get to some more interesting rocks, which is where they'll have one more checkout thing that they have to do, which is to use the drill for the first time. And that too is going to be a couple of week process of getting that shaked out. But once they get that done, then really they'll be ready to go. They'll be analyzing the rocks at Glen Elg, which is the next destination for them, and then they're going to book it back in the direction that they came actually and start heading toward the mountain.
How far have they gone so far? I mean, we're still only a couple of months since the rover landed, but it's actually made some pretty serious mileage already.
Well, yeah, it has actually driven more than the mission success goal for Spirit and Opportunity, which was, for them, it was 300 meters. Curiosity has driven a little bit longer than that. But of course, it's already been nearly the entire length of the original planned mission for Spirit and Opportunity, which was they were 90 sol missions. We're up in sol, I think, 77 right now on Curiosity. So it's this mission is definitely taking its time to get started. It's appropriate, but I don't think I'm alone in really wanting to see some more exciting work being done and definitely get on the road to get toward that mountain.
Yeah.
All right, so really that's all I've got to say from Curiosity. There continue to be really beautiful images coming down to the ground all the time, and it's well worth checking out the Raw Images website because a lot of the time there are lots of images that don't come down for weeks after they're taken, and so it's only very slowly that they're building up the pictures that they need to make these vast and beautiful panoramas. But since there's not a lot of science results, let's talk about the Division for Planetary Sciences meeting last week.
Before we do, I'd just like to let people know that they can ask us some questions. They can throw some questions our way, and if they want to, there's a bunch of different ways you can do it. The first thing is that if you're watching this on Google+, go ahead and post a comment in on Google+. If you're watching this on YouTube, you can post a question on YouTube. If you're watching this on anywhere else on the internet, you can just post a question on Twitter using the hashtag. I forget what the hashtag was. What was your hashtag?
TPS Hangout, TPS for the Planetary Society.
There you go, TPS Hangout. So you can use TPS Hangout, and then that will, then we'll see that question as well. That's it. Yeah. So, but by all means, you can ask, questions about curiosity. You can ask questions about planetary science, and as always, as the same threat that I make with Pamela, I'll make the same threat with Emily, which is I will take your question and I will make it more complicated, and just to demonstrate Emily's, massive knowledge on this subject. So go ahead and ask any questions while we kind of get through some of this, the DPS stuff, and then we'll go from there.
Thanks very much, Fraser. I totally forgot to mention that. So DPS. Scientific meetings, there's two big ones that I like to attend every year. The one is DPS, which just happened, and the other one is called the Lunar and Planetary Science Conference, which happens in Houston every March. And these are where more than 1,000, maybe up to 2,000 scientists get together, and they do 10-minute presentations on the current status of their work. In front of a lot of other scientists. There's Q&A at the end of the talk, and then they go right on into the next talk. That's usually all morning long. They do that, and even part of the afternoon. And then the rest of the afternoon, they have poster sessions. And poster sessions look a lot like science fairs, and,
I know.
and they feel a lot like science fair because you've got a poster up, you've got your hypothesis, your methods, your conclusions. It's all pretty similar. The one big difference is that at a science fair, generally there are some, big experts walking around questioning, sweating students about their work. Whereas at a poster session at a scientific conference, it's a more peer-to-peer thing. Scientists are often presenting work that's really only in progress, and often the people with the posters actually have questions for the people walking around and looking at their posters, and it's a really great opportunity to get some other expert opinions on work that you're doing and help generate new ideas. So the kinds of things that are discussed at DPS is part of the American Astronomical Association. So this is very much an astronomy conference, and that's reflected in the topics. There were lots of exoplanet talks. There were lots of asteroid talks. There were talks about the formation of the solar system, as well as talks on current missions like Grail and Dawn and Curiosity. But there wasn't a lot of time spent on Curiosity because it's really not an astronomy mission. It's LPSC, the Lunar Planetary Science Conference, where you get all the geology missions. So it was DPS last week that we got those really cool announcements of the exoplanet that's in a 4-star system, which was really quite awesome, and also the Earth-size exoplanet. Oh wait, that one, the first one that I mentioned, that one was discovered in part by the Planet Hunters, right? Which is part of the isn't it?
Which one?
The one with the 4-star in the 4-star system, or was it the Alpha Centauri one?
No, the Alpha Centauri was another survey. I forget what it was, but it wasn't. Okay. Yeah, this is where we
that's right. Okay, so Alpha Centauri was a different survey. So Alpha Centauri is the nearest star to us, and an Earth mass planet was discovered at Alpha Centauri, which is very exciting. One thing you do have to remember is that this planet is only in a 3-hour orbit around its sun. It is very close and scorching hot. Yeah. But the fact that there is an Earth mass planet that close to the sun means that there probably isn't a hot Jupiter in, another giant planet very close to the sun. And it opens up the possibility that there could be Earth mass planets in slightly more temperate climes in our nearest stellar neighbor, stellar system, which is really awesome.
So what were some of your favorite stories that you saw? Because I saw a ton of posts coming onto your blog over the course of the week, which amazes me that you have time to blog while you're doing it. I always find my productivity is just shattered at those kinds of conferences.
It's hard. A lot of the stuff that I saw was actually incremental progress on stuff that I've seen talked about at many previous scientific meetings. So one good example of that is these lakes on Titan, and specifically the southern seas on Titan. So Titan has these methane lakes. There are many more of them at Titan's North Pole than at the South Pole. And it's posited that one of the reasons for this is that Titan has what are called Milankovitch cycles, very similar to Earth, where the combination of the precession of the orbit and the obliquity and how elliptical it is, how tilted it is, and those things shift over time, and they shift in a systematic fashion, so that every 50,000 years, Titan's seasons they switch so that the northern, let's see, how does this work? The northern winters are more intense right now, and they get rainfall during the winter, and that's what fills up the lakes. And so when that switches every 50,000 years, then according to this hypothesis, you would have more lakes in the south and fewer in the north. And so to verify this hypothesis, one thing you might want to look for is evidence that there used to be bigger lakes at the south. And that's exactly what Ellen Stoffen found using radar images of the South Pole. There's only one good-sized lake down there that we can see. But if you look at the area around it, it's got it has a different appearance, a darker appearance with a bright outline that quite possibly is a coastline of what used to be a much larger sea at the South Pole. So I wouldn't call this proof of that seasonal shifting hypothesis, but it's certainly consistent with that hypothesis.
But I mean, we have situations like that here on Earth, right, where we have these lakes that people have been extracting the water out for irrigation, and things they're drying up, and you see those like fishing boat sitting on the side of, was it Lake Ural or Lake Baikal, and so you can see that these things are shrinking, but they leave behind some kind of evidence that the lake was actually larger to what its real scale is. And so, I mean, is that the kind of situation that we're seeing sort of old lake and then current lake?
Are you suggesting that the Titan?
The Titanians are
Titan government
irrigating.
Doesn't have good water policy.
That's right. That's exactly it.
No, well, no, I know exactly what you're asking. So it's a good question. You're basically saying, is it sign of cyclical something happening, or is Titan just getting drier, which is certainly possible. And so one way to look at that would be, can we see any change in the size of the lakes at the North Pole over time? Because if they've been shrinking, that's good evidence that Titan is in fact just getting drier. And so another guy looked at the radar data that we've had over the course of the mission, and Cassini's been there since 2004. It's been nearly 9 years. And so nearly 9 years.
2004?
Sorry about that. And so we do have some repeat imaging of these lakes in the north, and by every possible measure that he can do, and he did statistical analysis, there's just no evidence for any change in the shape of any of the lakes near the north. Now, you wouldn't expect a huge change based on just evaporation rates and stuff, but he didn't find any evidence for change.
You just think the tides must just be ferocious for those lakes, right?
Well,
with Jupiter.
Yeah, not so much with lakes. Tides on Earth are so big because the whole ocean communicates over the entire globe, and the lakes are pretty small, and furthermore, they're at the poles where you would expect the least amount of tidal action. But
Titan's moon is pretty big.
Titan is big. It's
no,
bigger
but I mean
than
the
Mercury.
fact that the thing that it's affecting it, in this case Jupiter, right, is so big that anyway,
That's
it would
true.
be interesting. Yeah.
Well, Titan actually experiences quite large solid tides, 10 meters over the course of each Jupiter day, which is big. And that tells us something very important about Titan, which is that it almost certainly has an interior ocean, much like Europa. Now, before you get so excited about Titan's ocean and the hydrocarbons and everything, the reason that Europa's ocean is particularly exciting is because it's under a layer of ice, and then there's the water, and then there's rock. And there's rock in a place that we know to be geologically active. So you have a lot of really exciting chemistry that can happen when you have hot, chemically rich water circulating through rocks. You don't have that at Titan or probably at Ganymede. You have an ocean perched between two ice layers, and the chemistry there is quite a bit less exciting. I'm not saying that it's not possible that there could be life underneath Titan, but Europa is still a better candidate than Ganymede or Titan are. So that's Titan. One of the things that I was most excited about is kind of an esoteric thing. It's the Grail Gravity Map of the Moon. And so this is the mission where Grail is two spacecraft that are sending radio signals to each other. And by When the one that's ahead travels toward a mountain, the mountain has a little bit of excess gravity. It pulls the spacecraft toward it, which increases the distance between the two spacecraft. And by timing these incredibly tiny shifts in the distance between the spacecraft, they've been able to develop a very detailed gravity map of the moon. And the reason I think this is so exciting is because it really does let you see things that are otherwise completely invisible on the surface of the moon. So one of the things that pops right out of the data is some pretty large impact basins on the far side of the moon that are completely invisible to either images or topography. But you can see the signal there, a perfect circle of a gravity high, which is what happens when you have an impact basin that gets filled. There's excess mass in there, and you get what's called a mass con, and you get this local gravity high over these impact basins. So that hasn't been published yet, but it's likely to be published somewhere around the time of AGU in December. So I'm really looking forward to that.
One of the real problems with attending these conferences is that it's also preliminary. That a lot of the cases, all the news releases and stuff that we as journalists go on, it's all been nicely packaged for us. Someone has sort of gathered together what they think are the most interesting stories and made them available. But in a lot of the cases with these conferences, it's all, it's the scientists presenting their rough notes, they're presenting their initial findings, and there isn't as much of this information to go on. So a lot of stuff that you're talking about, most people won't have heard about it because it won't have made these cycles,
And that's why you have to read what I write and tweet about it, and what other scientists tweet about it. There were a lot of scientists tweeting from this conference. There are 3 concurrent sessions, and there were at least 2 or 3 people tweeting from each session, and nearly all of them were scientists, and so they had really good perspective. There's one thing that I'll disagree with you on, Fraser, which is that a lot of this stuff it hasn't been published yet, but it's not stuff that has been worked on for only a couple of months. Each time I go to one of these meetings, I see the same guy give a talk about the same research, but it's been developed a little bit since the last conference. And so what you wait to see is, we tried this test and it didn't pan out. We tried this test and it did pan out. And here's another line of research that we're doing, or we added these particular empirical things into our work. So one of the talks that I like seeing every time is by one of the guys on the VIMS team. VIMS is the Visual and Infrared Mapping Spectrometer on Cassini. And one of the things that they're trying to do is to figure out what Titan's surface is made of. It's much easier to do for other planets and moons, but Titan is really hard because of its methane atmosphere, blocking most optical wavelength radiation from reaching the surface and then from getting back out to Cassini. There's a few very narrow, what are called windows in the methane absorption spectrum, where methane is transparent and you can get information back from the surface. And so they're basically, it really is like they're peering through very thin windows trying to get a sense of what the composition is. And so they've been doing this work ever since Cassini arrived to try to match the spectra that they get, that they can see through those windows, to see what that surface might be made of. It's not water ice. There probably is water ice just a little bit below the surface, but the stuff that's coating the surface is not water ice. It is most likely it's most likely aromatic hydrocarbons. And what that means is carbon-rich molecules that have carbon rings instead of aliphatic hydrocarbons, which are like carbon chains that you think of, like ethane and propane and that kind of stuff. But these aromatic hydrocarbons are pretty exciting, because they're one of I think uracil is one of the ones that they think might be there on the surface of Titan, and that's a component of RNA. So there's some pretty cool carbon chemistry happening on the surface of Titan. And this is the kind of thing where they have to guess what they think the composition might be. Then they have to take spectra in the lab under the same kind of conditions that Titan has, and then they match it. And they say, well, this doesn't work, this does work, maybe we can try this molecule that looks kind of like this, but that has other stuff added to it, and they have to go synthesize that and try it again. It's really hard work, and every meeting they have a little bit more results to tell us.
I wonder, aromatic hydrocarbons. I wonder if hence the name. I wonder if they would smell if your nose didn't freeze right off standing on the surface of Titan.
I think Titan would smell pretty bad.
Yeah.
Probably. So yeah, that's all about Titan. There was moon stuff. There was asteroid stuff. There was not a lot of results from Dawn. Actually, I was kind of disappointed by what we got out of the Dawn mission. And there are lots of interesting talks about what was going on with the formation of the solar system, and whether Jupiter. We know that Jupiter migrated outward, and then that caused problems in the outer solar system. But exactly how quickly it migrated and how severe those problems were is still very much up in the air. And I saw lots of talks discussing evidence for both sides of the story. One saying that Jupiter had to migrate fairly slowly. One saying that it had to have been the jumping Jupiter, the one that suddenly its apoapsis changed, and that caused majorly terrible things to happen with the what used to be the Kuiper Belt. So a lot of the
Right.
jury is still out on these various scientific results.
Well, the jury's still out on whether Jupiter is a help or hindrance even to Earth, right? Is it out there scooping up potentially dangerous objects, or has it been redirecting objects right towards Earth? So, are we better to have it out there? The Kuiper Belt clearly, isn't so sure about it. So,
Right.
I wonder sort of what impact, what
Ha, ha,
impact
ha.
this has really had. Yes, exactly.
And speaking of which, I wrote up some of the impact sessions today, and there was a really interesting presentation on an asteroid that actually poses a very small but non-zero risk of impacting the Earth. It's called 2011 AG5, and it has a 0.2% of hitting Earth in like 2053 or something. And it's one of those things where, in order for the impact to happen, it has to pass through a very narrow region of space near Earth on its next close flyby, which is in 2023. And if it passes through that region, which is what they call a keyhole, then its course will get deflected so that it's going to come back and hit Earth a couple of decades later. But we can't tell now whether it's going to hit us or not. And so the presentation was really about what's the appropriate action to be taking right now. How worried should we be? Should we be designing a mission right now? And the presenter, Steve Chesley, basically said, well, we need to, ideally, further observations will make its orbit well known enough, and we'll know that it's not going to intersect Earth. We don't have a chance to do those observations until the end of 2013, but we should wait for them. And if it turns out that this thing is on an impact trajectory, we're not going to know even then, but if it is on an impact trajectory, the risk will go up substantially. It'll become a 10% risk or so. And if that happens, then yes, we need to start designing a mission to go intercept this thing, track it, see if it really is on an impact trajectory, and if it is, try to push it just enough to get it out of that keyhole on its 2023 encounter.
Has it even crept onto the Torino scale?
I actually don't know yet. That
Okay.
information would be on the JPL Near Earth Object Program website, so maybe a resourceful viewer could actually go check that out for us and report back.
There's a great society called the B612 Foundation, which has been sort of looking into this exact question, which is, there is, it's not a question of if, it's just a matter of when some object is going to hit the Earth, 1,000 years, 10,000 years, who knows. And there's real value in reaching out and putting some kind of beacon on one of these objects to at least get a much better chance of understanding its orbit, its behavior when it passes through one of these keyholes. What is the long-term sort of movements of these asteroids? There's a lot of factors.
Tagging asteroids is really actually the best way to reduce the risk. You're not actually moving them. You're just putting a radio beacon on them. And in most cases, by tracking that radio beacon, you're going to be able to tell that its orbit is such that it's not going to impact Earth. So very likely you won't actually have to do anything beyond tagging it. So hopefully that's all we'll ever have to do. One of the interesting things from another presentation had to do with how we retire the risk by looking for more asteroids, and we've discovered quite a lot of the big ones, which of course pose the most serious risk. In fact, we found 98% quite likely of the very biggest ones, but as you project the discovery rates out into the future, we'll be finding a higher and higher proportion of the smaller ones, but we're still not going to get that 2% of those biggest ones. And the question is, where are those things hiding? They're hiding in resonant orbits. They're hiding in orbits that have multiples of Earth's orbit period. And then something would happen that would suddenly jigger them into a collision with Earth. And so to find those things, we need to have asteroid surveys that are not located at Earth. We need to have asteroid surveys that are located on spacecraft that are in some other orbit, and preferably closer to the sun than Earth, because then you're looking outward to find the asteroids that pose a risk to us. And I think the B612 Foundation is working on one of those missions, as a matter of fact.
Yeah, and you know, we report all the time on stories of asteroids where we're like an asteroid 100 meters across or just past the Earth within the this distance of the Moon, and the reality is that we had astronomers had no idea that it was coming by because it was coming from the Sun. That its trajectory was just hidden until the very last second, and you only realize as it's moving past, oh, there was an asteroid there. So definitely having some kind of space-based asteroid watch would be really helpful.
It would. I think that I'm ready to start taking questions, Fraser. I don't know if you have any lined up yet. Or
I
if
don't
should
have any
chatter
questions
a little
lined
bit
up.
more.
No,
Oh, my
I don't have any
goodness.
questions lined up. No. But I think there's a few other things I wanted to talk about that you actually blogged about this week. One is this amazing picture of Uranus, and I'm going to try and set that picture up so that you can talk about it.
Yeah, please do. Yeah, that was absolutely incredible. So here I was walking around the poster session, and I have to tell you, sometimes it can be hard to pay attention during the poster sessions. They serve beer, and you're having wonderful conversations with the other scientists, and you try to read the posters, and people put too much text on their posters. They really need to reduce that and just kind of present the main points with some big pictures to help you understand what they're trying to show you. Well, there's this one poster that had one big picture in the upper right corner, and this was that big picture, and it's two images of Uranus taken on successive nights with the Keck 2 telescope, which is equipped with adaptive optics. And they took these images very quickly so that they could get high signal to noise, and then they stacked them, which is a common thing to do in astronomical imaging. But they did some processing before they stacked them because Uranus rotates quickly, so they had to reproject them and line things up to account for Uranus's rotation. And then Uranus's atmosphere rotates at different rates at different latitudes, and so they actually kind of unwarped that as well. It's what I found interesting as I was researching this particular article is that it's the same people who took this picture are the ones who have been working for more than a decade with Keck to understand what exactly that differential rotation rate is. So it was their data they were using then to unwarp the pictures, which I thought was cool. But that wavy line at the equator and the tiny little cumulus cloud type things near the pole, I mean, they're not so tiny, they're not as big as Earth, but they're moon size. This is a giant planet after all, and those things are quite big. But still, they're smaller features than we've ever seen on Uranus before, because Voyager really wasn't equipped to see into Uranus's atmosphere very well. So I was just astounded by those pictures, and so were other astronomers. They were just walking by, and their jaws were dropping open when they saw these pictures of Uranus. They're like, "Did you send a spacecraft?" No, it's ground-based astronomy.
And you had a complete scoop on all of us because you just saw it in the poster room, which is something to be said for being there and walking the street. So that's amazing. And then the other thing that you just posted just a couple of days ago, or maybe yesterday, was this global view of Dione. Yeah, Dione. Yeah. Let me just see if I got that picture. Which is, again, it's hard to do this picture justice.
Yeah.
With putting this through the Hangout, because it's 5,000 pixels
5,000
across.
pixels across, yeah. And this is a perfect example of the kind of wonderful things that are waiting in NASA's archives. The data for this was from 2010. It's been sitting around for a long time. And actually, as a matter of fact, this image has been sitting on unmannedspaceflight.com since 2011, which is when it was first posted. And I asked the guy, "Can you give it to me in full resolution?" He was like, "Yeah, sure." He emailed it to me, and then I forgot about it. And I didn't post it until this year. And it's an amazing composite that shows this a view of it's one of my favorite moons because it's this ice ball. You can see all of its craters and the kind of battered history that it has, and yet it also has this wispy terrain.
That's right, yeah.
It's what was called wispy terrain after Voyager flew by, because Voyager didn't have anything like this kind of resolution. So all they could see were these white kind of streaks, looked like that they were painted across the moon. And so people theorized, well, maybe those are cryovolcanic vents that exploded. Well, when Cassini flew past and when we got images that have the resolution of this one, we now know that what looked like these wispy cryovolcanic things are in fact the bright walls of relatively recent fractures. So Dione, all of those things are fractured. Its crust has extended and split apart, which is actually, in retrospect, it's a natural process for icy moons for this to happen, because everything's cooling as it ages, and most materials shrink when they cool. And we see that on Mercury, where its surface has buckled and folded, where its crust has shrunk as the planet has cooled. But when it's ice, it actually expands as it cools. And so we're seeing the crust of Dione has expanded just slightly, enough to pull it apart in these places and make these fresh-looking fractures, which is what gives it that wispy look. Most of Saturn's moons have similarly fractured terrain from the same kind of process.
And I'm trying to think if there was one more. No, maybe not. Okay. No, that's it. So, yeah, those I thought were some of the really cool, images that you had posted, and some of the really cool stories that you've been working on for the last couple of days, the ones that I was jealous that you had caught first, and we were forced to tweet links to your stories as opposed to scoop you on them.
Well, I let
awesome
you guys
work.
have all the press release stories, and I just try to cover stuff that nobody has been paying any attention to.
Yeah. So no, we don't have any questions. So
Wow.
I know you've got to run. So why don't we just wrap it at half an hour? That's totally
All right.
fine.
Well, that's fine with me, and we'll tune in 2 weeks. I really hope there's actually going to be more to talk about with Curiosity's activities on Mars. By then, they should be driving again, and we should have much more to talk about.
Perfect.
All
All
right.
right.
Well, thanks for your help, Fraser. Again, I'm Emily Lakdawalla of the Planetary Society. Find me at planetary.org/blog. Give us a +1 or a thumbs up or whatever in order to indicate how you felt about this particular show. And stay tuned. I think, Fraser, are we going to be doing the weekly hangout?
Yeah, I think we're going to try and do the weekly space hangout tomorrow morning, and then we'll be doing the virtual star party on Sunday night. So
Okay,
that's
excellent.
yeah.
I'll be
Now
looking
we're into
forward
the
to
fall constellations. Jupiter is up dependably again, which is great. So it's been really beautiful. Yeah.
Excellent.
Full
I look
moon,
forward to
though.
that.
Anyway, all right. We'll see you later.
Thanks. I'll see you around, Fraser.